Welcome. I will be your moderator for our Other Favorite Nut sessions. My name is Jerry Van Sambeck, and I worked for more than 40 years with the U.S. Forest Service in the Midwest as a research tree physiologist and the University of Missouri Center for Agroforestry, working on walnut, oak, ash, and pecan. I've been a member of the NNGA and the Missouri Nut Growers, totaling more than 55 years. At this point, I will ask Gina to give us a short video clip about the NNGA website. Oh.
Gina, we don't hear your sound.
Sorry, everyone. Let me start that again. I don't believe I shared my audio, and I believe I need to do that. Go back in time here. We'll just start this again, and I will mute myself. Thank you, everyone. Hello, NNGA members. I'm Gina Zimbardi, your Communications and Membership Manager. I want to thank all of you for being here today, and I want to welcome all of you to our new website. I've made a number of changes, especially to our membership-only area. I'd like to go over a few of these changes today. First, as you can tell, we have a whole new landing page that should be easier and more fluid to navigate. As you can see on the left-hand side, you have quick action buttons to get to what you really want. First, you have a donate button. That donate button will take you directly to our PayPal donation page to donate to the NNGA Research Fund. We appreciate any and all donations you can give us. It really keeps us going and allows us to fund research to help temperate nut trees. So thank you. Next, you can vote in the 2021 elections. Because 2020 was, well, an off year with COVID, we had to change a lot of things online, and that's the reason we're having a virtual conference today. So to get to our, to allow you to vote for our board meeting and for our members and for nominating committee and all of those important things that we need to run a successful nonprofit, I've created an online form for you to fill out. So if you're a member of the NNGA, please, by the end of Tuesday, go in and vote. It's very important. And as you can see, you can vote for things like changes in the Constitution and bylaws, as well as future board members. So please do that as soon as possible. The next thing is very new, and that is our forum. That's right, I've created a forum for paid members, so all of you who do not have social media and not on our Facebook group can go in and introduce yourself, ask questions, post pictures, post cultivar inventory questions if you have a cultivar you want to show off, or if you're looking for something specific, and ask questions to our experts, or even answer questions. So if you're a member, please check it out, introduce yourself. We're looking forward to getting to know you. Lastly, you can check out our nutshell. So as before, you could read our nutshell, but I've really updated the page so it's a little bit more visually pleasing and it's even easier to use. So if you're looking for a specific year or just looking to look at the most recent nutshell, you can easily find it here. So all you need to do is click on an edition of the nutshell and it'll bring up a beautiful PDF. So that's our new member area. Please check it out at your earliest convenience. If you are a paid member of the NNGA, you must reset your password before you can access this new area. We changed how we do memberships. I appreciate all of your patience as we change things and work out new kinks and bugs. So to change your password or to reset your password, it's very easy. On our website, go up to the member login logout and go down to password reset. That should take you to a page that will very easily allow you to reset your password. If you have any questions or concerns, please feel free to contact me at contact@nutgrowing.org. We've made a lot of changes and there may be some bugs, and I appreciate your patience. So if you have any questions or concerns or any issues that aren't working for you, please contact me and I'd be happy to help you. Thank you. Have a great day and enjoy our conference.
This is your moderator again. Some additional housekeeping details before we get started. If you have questions of any of the presenters, please enter them in the Q&A at the bottom of your screen. Periodically during the session, click on the Q&A to see what questions have been asked by others, and click on the hand for those questions you also would like to see answered so they get upvoted. I will be selecting questions from this area for the Q&A session from 12:15 to 12:45 based on the number of votes. During the presentation, if you click on the right-hand side of a slide, you can drag the margin to the right to enlarge the slide on your screen and minimize my panel. Clicking on chat will allow you to send a message to either all participants or the organizers. I will not be monitoring the chat section. Neither the Q&A or the chat boxes will be recorded. So take notes if you see links or other information you want to have in the future. If you have not done so, this morning is a good time to go to the NNGA website and vote on the bylaws, officers, and board members as Gina just instructed. Also, if you have not posted your questions, you have our keynote speaker, Diane Beardsford Kroger. Please go ahead and enter them in our Q&A, and I will get them forwarded to her session this afternoon. If you have any technical difficulties, please call 717-686-2000 as shown on the screen, and Gina will assist you. We have 6 presentations in our other favorite nut sections that will run back to back before we have the Q&A session. The order has changed from earlier versions of the agenda. Can we move that to the to minimize some computer issues moving through the presentations? John Kelsey is a retired engineer and landowner in West Virginia, who I would call more than a citizen scientist. As Sean Mullenbacher mentioned yesterday, John plans and conducts his own farm experiments and is always ready and willing to help others with analysis of their data sets. John will be discussing the natural pruning of black walnut for quality timber. Keep an open mind about the approaches he presents for opportunities to incorporate into orchard establishment for nuts and timber. Nick Labonte will address gene conservation of butternut. He is currently the geneticist for Region 9 of the U.S. Forest Service, looking at adaptability of trees to climate change. In this work, he is utilizing existing plantings and planning for new plantings that may eventually be converted to seed orchards. He is a graduate of Purdue University, having worked on butternuts and chestnuts for his master's and doctoral research. Bill Dieter will discuss issues associated with finding and growing hybrid butternut trees. He is an active member of the NNGA and the Indiana Nut Growers, who works with other researchers. Together, they work on germplasm collections and repository establishment in northern Indiana for chestnut and hybrid butternuts for evaluation of cold hardiness and disease resistance. Rod Hart is a member of the NNGA, has been a member of the NNGA for more than 20 years, and is our go-to guy for information on nut issues within the industry, including almonds, pistachios, pecans, and walnuts. He had computer issues, so his daughter, Leslie Kudemeyer, will give his presentation on problems associated with pollination in almonds and pecans. Bill Reed is now a fruit and pecan grower after recently retiring from the pecan experiment station in Topeka, Kansas. He is my go-to guy for questions on pecan, and he would say an all-around nice guy. He will be discussing how to train young pecan trees for future nut production. Carl Albers is a walnut grower and longtime member of the NNGA and New York Nut Growers. He will be discussing part of his project he will be discussing part of his involvement in the New York Nut Growers Association's English Walnut Project to collect and evaluate English walnut for use in New York. At this time, I will turn it over to Gina to begin the presentations.
Hello, I'm John Kelsey, a black walnut and hazelnut grower in West Virginia. We have a 40-acre black walnut plantation planted between 1970 and 2004. Our result progressed from total failure to spectacular. Somewhere by accident and neglect, we finally managed to grow some beautiful veneer quality black walnut. In this presentation, I'll describe how that happened and the science behind it and why you might want to do it. This presentation has 6 parts. I'll describe how you might want to grow veneer quality black walnut, how a poor black walnut site can defeat you. Our general method exploits black walnut's shade intolerant nature and uses conifer trainers to naturally clear the lower walnut stems. The final part describes the proper timing and the possible layout for future planning. Here's Grandpa's old field, 3-cornered and too small for modern agricultural machinery. You're getting tired of mowing it. What would happen if you just quit? Land parcels are continually being divided by drainage and inheritance. They becoming practically small for agricultural use. Such properties are common sight throughout the temperate East. After a few years, explorer tree species and invasives take over from the weeds and briars. The invasives are shown in red. Here's a West Virginia price report for standing timber, and on the right are the explorer tree species in Grandpa's old field. Notice that all the explorer species fall in the other hardwood classification at $44 per 1,000 board feet. And black walnut tops the list at roughly 20 times more. Here is an Indiana price report for black walnut, saw logs, and veneer logs, this time delivered to the mill. Notice that veneer logs are worth about 5 times more than saw logs of the same size. Here's why you might want to grow veneer black walnut rather than abandoning Grandpa's old field and just letting stuff happen. It's going to become a woods one way or another. Why not an elite high-value woods, the pride of your property? Now that I've convinced you to grow veneer black walnut, I need to hedge a bit and admit that it's not possible just anywhere. Here are some common types of sites and the tree species that like to grow there. Black walnut wants the same ground that will grow 200 bushels of corn. Here's our beautiful upland planting. It was a perfect failure. Black walnut might just survive on an upland or terrace site, but not grow with the vigor that we want. Here's the Goldilocks bottomland site. This is Hugh Pence's 100-acre plantation near Lafayette, Indiana. This is our 1980 planting, which floods every year. The water runs out in a couple of days and does no harm. In fact, some new soil is left behind, which can grow 15-foot pokeweeds. Here it is on a nicer day. Another kind of low area might be a hydric area. That's a saturated soil that can go anaerobic and really stink. This is a habitat for a completely different kind of plants like cattails. If you look closely at Grandpa's old field, there are some darker areas with march grass. That's a no-go for most tree species. It might be drained for ag crops, but not for trees. We want to grow big trees, and big trees are too smart to grow more than their root balls can support against wind and ice storms. Big trees need big root balls. It takes 8 or 10 feet of usable soil to grow unsuppressed black walnut. This is the way a black walnut wants to grow. Out in the open with many side branches and cover the ground with nuts. This makes a lovely spot for a picnic. However, this is not what a veneer buyer wants. We need to trick the walnut to grow in a completely different shape. In some rare cases, a walnut grows the way a veneer buyer wants. How can a shade-intolerant black walnut grow deep in a forest where it's not supposed to be? How's that happen? However, it does happen, and we need to understand it and duplicate it. The deep forest top-quality walnut couldn't have grown up before the forest, or it would have been a limby wolf tree. It couldn't have tried to grow up after the forest, or it would have been shaded out. Nearby trees need to be threatening, but not killing. The lower part of the walnut had to be heavily shaded and clear sky above. This is going to be tricky. It's all about controlling the shading. I'm an amateur scientist. Just labeling black walnut as shade intolerant is not good enough. Shade intolerance should be measured. Here's an area in our 1998 monoculture planting. I bought a $20 light meter. That was a mistake. On an overcast summer day, I measured the light intensity out in the open, then measured again well inside the plantation. Surprise, I got 24% everywhere. This was a eureka moment. Not only are walnuts shade intolerant, every branch individually is shade intolerant. As the tree grows taller, it adds branches and leaves at the top. It gets darker at the forest floor level. When the underlight drops below a critical level, lower branches die, defoliate, and therefore increase the light back up to the critical shade tolerance level. It's self-limiting. So how do you measure a species shade intolerance? First, spend more than $20 for a light meter. Then, on an overcast midsummer day, measure the relative light level under a closed canopy of a monoculture. I also noticed that the depth of green crown was about 25 feet, top to bottom. So 25 feet of walnut foliage reduces the light level to the critical 24%. As the plantation grows in height, the 25 feet of green foliage moves upward, adding to the top and shedding branches at the bottom. The crown depth, top to bottom, stays the same, and the light level everywhere stays at the critical shade tolerance level. Now, here's the problem with an unmanaged walnut monoculture. A new side branch is born at the top of a tree. The tree's height grows 2.5 feet per year. In 10 years, this branch will be 25 feet down from the top in the crown's bottom death zone. The trouble is that a 10-year-old branch will be about 3 inches in diameter and have a heartwood at its center. The branch doesn't just saw itself off. The dead branch loses all its pathogen defenses. Fungi attack, then termites, then woodpeckers, then a squirrel den. Once the tree's perimeter defenses are breached, the fungi are in for the duration. So here's an important point. Walnut is a lousy trainer for walnut. What's needed is heavier shading to get the side branches off sooner and smaller. We just happen to have a white pine monoculture we planted in 1980. Healthy white pine produces a much denser shade. Look at the weeds. They can't take 5% either. So could white pine be used to train black walnut? By accident, we tried it about 20 years ago. The pines were planted for Christmas trees in 1992 and shaped each year. As the trees were sold, we planted black walnut seeds. Both the pines and the walnuts are now 55 feet tall. The walnut crown height, top to bottom, is only 10 feet, and natural pruning on the bottom side of the crown is still working. In summary, number 1, all plants are shade intolerant, some more so than others. Number 2, 25 feet of black walnut crown reduces the light level to walnut's critical shade value. Number 3, it only takes 10 feet of white pine to reduce the light level to black walnut's critical shade level. Conifer trainers not only have the dense shading we want, their cone shape is less competitive in the upper canopy. Where conifers are shaped like geometric cones, walnuts are shaped like inverted cones, a perfect fit. We know that white pine and bald cypress produce enough shade and grow at the right rate. We're testing a few other conifer candidates in an experimental planting at Blennerhassett Island State Park. Scots pine is unsuitable because it is killed too soon by the juglin hormone in the soil from the walnuts. Here's black walnut being trained by bald cypress's dense shade. Check out all the weeds. Few weeds can bear the 4% light levels. This is Tom Jones planting in southern Ohio. In part 5, I'll show you the important difference between manual pruning and natural pruning. I can tell you right off that manual pruning is a lot of work with a poor result. Here's how you'd be instructed to prune. Don't damage the branch collar, C. It has a special ability to close wounds. Here's how manual pruning progresses. The root collar closes mostly from the sides. If fungi made it to the heartwood, they're trapped inside and happy. The final result. Now the sequence for natural pruning. The branch is isolated by the tree because it's supplying less energy than it uses. It went to the dark side of the energy balance. The capillaries feeding the branch are plugged inside the branch collar by pectin. The branch dies and loses all its defenses. Fungi penetrate and structurally weaken the branch. The branch collar surrounds the branch, but it's not attached, a good place to hold moisture to collect and feed the fungi. How smart is that? The branch breaks off inside the branch collar. Even a master pruner could never get his saw in there. The branch collar closes the opening equally from all sides. The imprint of the lost branch left in the bark, called a cat face, is soon lost to the uniform diamond bark pattern. Veneer buyers are masters of reading cat faces to estimate what's underneath. Each of these steps will proceed faster with smaller branches. Here's one of our white pine tree and black walnuts. Obviously, it once had side branches, but if you can find a cat face on it, you have better eyes than me. In contrast, here's some of my shameful pruning work. This is already the heart of some future butt log. The point here is, some small trainer tree 15 feet away, no matter the species, isn't going to help. Unless the trainer is close by, it's an open setting during the important years when the skeleton of a butt log is being formed. The takeaway from part 5 is that trainers can do the dirty work of pruning for us and do it better than we can. But they need to be nearby when the walnuts are planted. Here's an ideal planting layout in Missouri. Oddly, it was planted as shade for livestock, not timber, so the pines were soon removed. This is not the right timing, but I like the layout. A tree farm owner is stuck with his plantation layout for life. To design a good layout, one needs to consider harvest time, then think backwards to thinning and to planting. Here's the spacing and timing sequence we're using in the Blennerhassett experimental planting. First, we planted the conifer trainers 16 feet apart. This is the hard part. We need to wait until the trainers are close enough to do their job. We have 4 different timings. 1/4 are planted with no delay. That's for control. 1/4 when the aisle's close to 8 feet. 1/4 when the aisle's close to 5 feet, and 1/4 when the aisle's close to 2 feet. We want a certain geometry, not a certain delay time. We thought 5 feet was the right answer, so we bracketed plus and minus. About the last time you can get through with a lawnmower pulling a cart, plant the walnuts. Actually, we were selling Christmas trees. I planted 4 seeds around each stump. The walnuts begin to be shaded right away, and they have to stretch up. The results look something like this. The walnuts stretch and soon catch up with the pines. The side branches are small and they're doomed. It's hard to get a good picture of walnuts closely surrounded by pines. Here I stupidly cut some down because I needed some straight poles for hazelnuts. We're now at year 18. Both the pines and the walnuts are now 55 feet tall. It looks like this. No cartoon this time. Looking up in the canopy, the natural pruning process is still going on. The walnuts are slowly winning the battle for sunlight, and I see no reason to do anything. This is another kind of do-nothing forestry. The pines are not as healthy as they were. The walnut's juglin is also winning the battle underground. Here's an idea how one might begin. Then, as the trainer aisles close, plant the walnuts, leaving some access aisles. There are plenty of walnuts here to pick for crop trees. Our access aisles now look like this. These aisles are very useful. There are many problems in our monoculture planting that don't exist in this heavily shaded area. Two such problems that come to mind are frost cracks and bird pecks. The economics of growing walnut are too complicated for my brain, but I know the time value of money is a killer on such a long-term project. For sure, if you have to borrow the money for good land, it won't work. You're actually safe from making this mistake because no bank will loan you money without a payment for 100 years. So here's the whole process in a nutshell. A, walnut wants to spread out and cover the ground with nuts. It needs to be tricked. B, black walnut is a lousy trainer for black walnut. And C, you have to wait so the trainers can do their job. The Walnut Council is a great organization for walnut growers, foresters, and forestry scientists. Many of us belong to both the Walnut Council and the Northern Nut Growers. The ScalePit.com is the Kelsey website where I post most of what I've learned about growing walnuts and hazelnuts. There's also information about the Blennerhassett experimental planting. Here's how Grandpa's old field might look if you take some action. Thanks for your attention, if you're still awake.
Hi, I'm Nick Labonte. I'm the geneticist for the eastern region of the U.S. Forest Service National Forest System. I'm based out of Milwaukee, Wisconsin, and I am here to talk to you about butternut gene conservation in the National Forest System in Region 9, also known as the Eastern Region. So the Eastern Region covers a large part of the Midwestern and Northeastern United States, including a lot of overlap with the native range of butternut. And a majority of the national forests in Region 9 have at least some significant native butternut population, some more than others. And the native range map of butternut, I always point out when I throw it up there on a slide, is a little bit deceptive. Butternut's much more abundant in some parts of its range than others. Just as a case in point, the Nicolet National Forest, the green star there in northern Wisconsin, probably has more butternut than any other national forest in Region 9, and it is located right on the far northern edge of the species native range. The Monongahela, in West Virginia also has a lot of butternut, and the others all have some. So wherever it occurs in Region 9 and just to the south in Region 8, butternut has experienced significant population declines due to butternut canker disease and a lack of regeneration caused by forest successional issues. So in some parts of its native range that you see there, butternut has simply been largely extirpated, reduced to a few widely scattered trees, while in other areas it's still occasional, rare, but occasional to locally abundant species. So to start the presentation, I'll just go over some conservation challenges with butternut and how we address them in the National Forest System. So in the National Forest System, we look at butternut as a native species that we have a charge to conserve. It's less of a tree breeding problem for us and more of a how to preserve butternut and try to keep it on the landscape in the face of the challenges that it is struggling with right now. And the main conservation question, I guess, as it is for a lot of species, is just where will the next generation of butternut come from? The mature trees that are left on the landscape are mostly declining. There are not a lot of great sites for butternut to regenerate on. So it's a real question of what is the next generation of butternut going to look like? Where is it going to grow? Tied to that question is another one, which is, can we prevent the irrevocable loss of butternut genetic diversity as that older generation of butternut that's on the landscape now dies out? So many of them are dying because of cankers before their time, but butternut was never a long-lived species, and it rarely lives to be 75 years old. So it's a short-lived, early successional species that doesn't produce a lot of seeds. So we kind of have a two-pronged problem for butternut with this lethal disease, as well as aspects of its biology that make it hard to regenerate. And finally, another question that's more of a research and less of a management question is, are surviving trees resistant? There are still butternut out there in the landscape that look pretty good. If we were to collect seed from those butternut, propagate them, let them cross with each other, would that be a way to increase canker resistance and generate canker-resistant planting stock? Unfortunately, I just have to tell you that we don't really know. The evidence so far has been inconclusive. It has not been encouraging for the idea that these surviving trees have resistance that they can pass on to their offspring. But I would still say it's inconclusive. And our efforts in Region 9, working on butternut gene conservation, address all three of these questions in different ways. Most of the effort on butternut in Region 9 has been devoted to creating a region-wide collection of butternut clone banks. So you think about a seed bank where seed is dried down and frozen under very stable conditions so that it remains viable for a long time. That doesn't really work with butternut. There are ways to cryopreserve butternut embryos for a long time, but in terms of whole nuts, butternut is a recalcitrant seed, which means that it can't be dried enough to preserve it under freezing conditions over a long period of time without killing the embryo. So seed banking is not a great solution for preserving butternut genetic diversity, but clone banking is a little better. So grafting wild butternut genotypes onto rootstocks, growing them in a controlled setting where we can kind of manage competition, manage deer browse, make sure these butternut clones have everything they need to be the best butternuts they can be, and sort of freeze on the landscape as a living tree that genetic diversity so that it's not lost when the parent tree dies out in the woods. We don't have a great way of managing canker disease in these orchards, but we can at least monitor it and try to protect the trees against canker as well as we can by maintaining kind of good airflow, not a lot of rank vegetation around the trunks, which we know kind of makes butternut canker worse by creating really humid conditions close to the tree's bark. And if there's a need to plant more butternut, which I certainly think there is, clone banks that are well maintained and protected can be a good place to collect seeds. And since the trees are grown at a fairly wide spacing, they tend to be good seed producers. You could call these sub-regional clone banks. We didn't want to create just 1 or 2 clone banks for the region because it's such a huge area in Region 9. So we would rather establish clone banks in more local areas where the genotypes are are more adapted to the local conditions and will perform better. So, I mean, for example, our seed orchard in Region 9 is in northeastern Wisconsin. That's not an awesome place to grow butternut that originated in southern Missouri on the Mark Twain National Forest. So, also, as a gene conservation effort, you don't really want to put all your eggs in one basket. If something goes wrong with the planting, if we had a bad freeze at Orso that eliminated some of the southern genotypes, or you know, ended up planting a big clone bank in an area that turned out to be really vulnerable to butternut canker, rapid butternut canker mortality because it's humid or has bad airflow or something like that. You wouldn't want that. So we've established them on a variety of sites near or on national forests. The scion material that's contributed to the clones in these plantings came from both on national forests and around them. For example, the planting in Ohio contains material from the Wayne National Forest itself, but also from neighboring areas in Indiana and Kentucky. The work plan here is collect scion material, graft it, and establish plantings. And both of these steps included a lot of cooperation with partners, pointing us to where butternut occurred, allowing us to collect scion material off of their property, and in some cases even providing land to host the plantings themselves. So one way that you can collect scion material from our butternut is by shooting it out of the tree, which you see Carrie Sweeney, who's now our regional silviculturist, but was our seed orchard manager at the time, shooting scion material out of a butternut tree in northern Wisconsin. So we only do that in more remote areas like national forests, so always safety first. But there are other ways. You can use a big slingshot to get scion material from the top of a forest grown butternut, or you can hire a climber to go up there and get some. So here's our sub-regional clone bank locations and planting dates. We have one in Pennsylvania with material from in and around the Allegheny National Forest, the Green Mountain and the Finger Lakes National Forest, the Hoosier in Indiana, the Mark Twain in Missouri, the Monongahela in West Virginia, the Wayne in Ohio, and finally the original butternut clone bank for Region 9, which is all material from in and around the Nicolet National Forest and adjacent parts of Wisconsin and Minnesota. So that one is at our seed orchard, the Oconto River Seed Orchard, and that one was started way back in 2004 and 2005. It's kind of tricky to nail down the exact establishment dates for these because some of them were started and didn't have good take on the grafts, so were mostly replanted in subsequent years and that kind of thing. So, but these are the extant butternut plantings we have as clone banks in Region 9 currently, and so most of them have had a chance to get pretty well established. So again, here's the workflow on how this works. Step one is locate trees. Because our mission in the National Forest System is conserving native species, we're interested in wild forest-grown butternut primarily, and at least for now, we are avoiding the Buart nut or butternut heartnut hybrids that are fairly common out there on the landscape, especially in planted settings. So locate trees, get a good lead on the locations from a local forester or landowner who's interested in tree conservation. Collect some scion material. That takes place in the winter. Then that scion material is grafted onto rootstocks in pots and grown in a greenhouse. We typically use black walnut rootstock for butternut grafts. They're compatible, it works fine. And then once you get a sense of how many grafts take, which is usually about half of them, you grow them up for a couple years in the greenhouse. That gives you a chance to analyze some leaf material for hybrid DNA if needed, again, because we're avoiding hybrids, the DNA is an extra check in addition to the phenotypic characteristics that allows you to eliminate potential hybrid material from the planting. And then hopefully somewhere around the time you're collecting sign material, you can work with land managers on the national forests or with cooperators to identify a planting site and then prepare it and plant it once the grafted material is ready. So what do these plantings look like? They do have nice interpretive signs. They're planted in a variety of locations, both on and off national forests. They are all protected by some form of deer fencing, either a fence that encloses the entire site, like the one you see in the picture, or individual fences around individual trees. Most contain about 50 grafted clones, which is pretty impressive. I mean, you saw how long the list of clone banks was. There's a little bit, some material is in both clone banks, like there are some that are in the Wayne and the Hoosier National Forest clone banks, just because those forests are so close to each other. But still, I mean, 50 clones per clone bank is pretty impressive, and it represents a huge sign collection and graphing effort. And there isn't just one copy of a grafted clone in the orchard. Typically, we aim for around 5 copies of each clone, just in case something happens to one of them. And the grafted material was genotyped to avoid including hybrids with Japanese walnut. Some of that was with university collaborators like our friends at Notre Dame, who are excellent at genotyping butternuts, as well as the National Forest Genetics Lab. Here's what some of these plantings look like immediately after they're established. The Allegheny, Green Mountain, abbreviated as GMFL there because the Finger Lakes is technically part of that national forest. The Wayne just looks like a bunch of grass, but that planting is doing quite well now. The Monongahela was the youngest of these plantings. The Allegheny again there, and the Hoosier. So the Hoosier planting does not look like it's on a national forest, and that's because it isn't. It is actually on the grounds of a furniture factory in southern Indiana. But the advantage of that is the entire site is fenced, so we don't have to worry about any deer damage, and it's obviously a very nice, open, pretty manicured site. So that's, in terms of seed production, that Hoosier National Forest Orchard is actually the best one we have in the region. So just to review the purpose of the plantings for the National Forest System and for the community of people who are interested in butternut conservation at large, which I think includes the northern nut growers. At the very least, we want to preserve butternut genetic diversity for as long as we can in these clone banks, just to forestall the loss of butternut genetic diversity on the landscape. They won't last forever, but they will last for a while, and if needed, we can regraft and reestablish them to maintain those clones. Ideally, they will produce seeds that can be used to grow butternut seedlings to establish on national forests or on other lands if the national forests are not interested in planting them. It's not always easy to fit butternut planting into a silvicultural prescription, so hopefully, if the seed is not used up by national forests, it can be made available to other partners to grow. And what they don't do is help us answer that question about whether any of the survivors of butternut canker have canker resistance that they can pass on to their offspring. So to address that, we have another planting that's even bigger. Our Bell Center, Wisconsin butternut resistance test is probably the largest butternut planting in the world. I'm just going to go out on a limb and say that it probably is. It's a very large test planting that was established on Wisconsin DNR land in collaboration with staff from the DNR in Wisconsin, National Forest System, Forest Service Research, and Forest Service Forest Health Protection. So all three sort of areas of the Forest Service contributed here, as well as the University of Wisconsin system. It is located on a site with naturally occurring butternut in southwestern Wisconsin. Some of you may be familiar with the Driftless area. It's very scenic, but it also has a fairly large butternut population and continues to have a decent butternut population. And so we were lucky to get a site there, and I think it's a pretty good site for this planting. It's in a valley, but it's far enough from the actual creek bottom that you don't get a lot of really rank vegetation and stagnant air. So it's a good spot. The purpose of it is to test surviving butternut families. So this is not grafted. These are all seedlings of parent trees. Test them for differences in their response to butternut canker infection. So obviously, people have tried to identify differences in butternut canker resistance among surviving butternut families before and have still come up with inconclusive results. So what are we doing differently this time? Butternut researchers have thought for a while that artificial inoculations might get around important resistance mechanisms in butternut bark. So you could call it the traditional artificial inoculation is to make a hole in the outer bark of the tree and tape a plug of agarose with butternut canker fungus growing in it into the wound and then watch the infection develop. So it's based on what's done in the chestnut blight resistance breeding program. But that's not, butternut canker doesn't typically infect the tree through big open wounds like that. It develops in small fissures in the bark and things like that. So, or even on leaves and first year growth. It's not like chestnut blight where it's very specific to stems, and it's not like Dutch elm disease where it infects vascular tissue specifically. It just creates these little necrotic cankers on whatever butternut tissue it can find. And so the question here is, how would we do a natural inoculation in a controlled way where we would have valid research results? So the strategy that Paul Barang, the previous geneticist, and collaborators came up with was to have a sacrificial row of random butternut seedlings for every 2 rows of test trees. Let the sacrificial trees grow up with the test trees, then artificially inoculate all the sacrificial trees so we know they will develop canker infections, and then allow the cankers on the sacrificial trees to sporulate and naturally infect the test trees. So if it works, I think this will be the best test of the genetics of butternut canker resistance yet. And there is a chance that trees will develop canker naturally because there is wild butternut in the hills around this planting. And I was actually there just a couple weeks ago measuring it with James Jacobs, who from Forest Health Protection, who's pictured here with me, and we found that a small percentage, I would say 2 to 5% of the trees have some natural canker development, truly natural canker development from wild inoculum, and that but it's not showing they're minor cankers and they're not causing a lot of mortality currently. So that's good. We wouldn't have as good of a test if everything just died from natural canker infections in the early years. So some research specifics, it's a resolvable and complete block design, so we should be able to do a good statistical analysis to see if any of these families are more resistant to butternut canker. We've got 39 butternut seedling families and 6 hybrid seedling families. So they're half sib families because they share a mother, but the fathers, there are presumably many fathers contributing to each of these families. And there's about 40 seedlings per family. So that comes out to greater than 1,600 test trees and about 1,600 spacer sacrificial trees. So pretty substantial planting of butternuts. And there it is, being planted with Jim McKenna, familiar face there, the world's foremost butternut planting expert. Here's what it looked like in 2018, right after it was planted. And here's what it looked like this July. So you can't really tell how big the trees are here, but if we go back a couple slides, remember the picture of myself with James measuring it, that some of these butternut trees are more than 2 meters tall. This planting does include hybrids, and they tend to run a little larger than the plain butternuts currently. So what are current conditions like in this planting? There's a very low incidence of truly natural cankers, as I said, 5% or less. Tree vigor and growth is generally excellent, and the trees have actually recovered pretty well from some dieback that occurred early on. There were some trees that had 90% dieback recorded in the first pass through the planting in 2019, the year after it was planted, that now you can't tell. They've grown back really well. So tree form is not outstanding. Butternut tends to really spread out if it can, so they're very branchy little trees, but that's okay. We're not trying to generate butternut saw logs. We're just doing a research project here. Some other interesting observations. Japanese beetles seem to really like eating the butternut Japanese walnut hybrids. We didn't notice a lot of them on the regular butternuts, but they were chowing down on those big, vigorous hybrids. So just interesting anecdote there. There did seem to be some frost damage. I haven't analyzed it yet to see if that was correlated with the more southern families exhibiting that kind of tip dieback and stuff. But this planting does include material from all over butternut's native range, so it should be interesting for a lot of reasons. And I'm glad the hybrids were included. We know that some hybrids tend to be a lot more resistant than regular butternuts, so that'll provide us sort of a control to see, okay, the trees that we expect are going to be a little more resistant, if they aren't getting sick, we know that we don't, they're happy trees, they're growing on a good site. So it'll be interesting to see how variable some of these hybrid families are. It's just open pollinated seeds, so they could be F2s where you had a hybrid crossing with a hybrid, and they could be back crosses where you had a hybrid crossing with a butternut. So it'll be interesting. What's the next steps? Is to just keep monitoring and maintaining this planting with mowing and that kind of thing, and inoculate those sacrificial rows in the next 2 to 3 years. So that will be the start of really finding out if any of these trees are more resistant than the others. Well, thanks for your attention today. I'm happy to have the opportunity to present to the northern nut growers, and looking forward to getting some interesting results on our butternut research project and hopefully providing a butternut seed source and genetic reserve for the species in the coming decades. If you have any questions about butternut in the eastern region or just butternut in general, feel free to email me. My email address is there, and that's my phone number, so you can call as well. All right, thanks again, and thanks for all you do at the Northern Nut Growers. Bye-bye.
Hello, my name is Bill Dieter, and today I'm going to be speaking about hybrid butternut trees. I've been graciously asked by the NNGA to give a little brief synopsis of the information I have on butternuts, hybrid butternut trees. I've been growing them for perhaps 18 years now, and collecting the seeds from them. So I'll just get started right now with the discussion in this video. What you have in front of you right here is a type of hybrid butternut. This is a Persian cross with Juglans cinerea, pure butternut. This tree is approximately 16 inches in diameter. I couldn't get the whole tree in the picture, but I wanted to show the bark. There's a difference in bark on hybrid butternuts, and there are several types of hybrid butternuts. This is one that is probably the rarest of the lot. Not too many crosses happen between Persian and pure butternut. This was actually a controlled cross about 35 years ago. What I have here is a example of the bark of a pure butternut, Juglans cinerea. This tree here is approximately 50 years of age. It was healthy at the time I took this picture. Note the bark is quite a bit different than the previous photo. This is more like long furrows with kind of flat topped, indicative of pure butternut. This picture I have here is a hybrid butternut. This is the most common cross, which is the Juglans, that's Japanese walnut, crossed with our pure butternut, Juglans cinerea. This tree is actually quite common to find in different areas, usually as a planted tree in people's yards. They grow very rapidly. I have seen some of these trees of over 5 feet in diameter, open grown. Here's a picture of one. This is an open grown tree in a person's yard. This tree below branch, I measured around, it was 5 feet 1 inches in diameter. It's only about a 50-foot tall tree, but it's about 65 feet wide. The crown, it's completely in full sunlight, and it is a very heavy producer of nuts. I usually get most years between 3,500 and 4,000 nuts from this particular tree. Best year I had was a little over 7,200. This is a picture of a Japanese walnut. Actually, I gave this as a seed to a friend, and he grew it. And it is probably about 17 years old now, and is 21 inches around the trunk, or through the trunk, I should say, the diameter, right below the lowest branch. Japanese walnuts are very rapidly growing trees. But they want to branch early, and they want to get really wide, especially in the sunlight, and that's where they shine. This tree started producing nuts at about 7 years of age, and so has been a good producer for quite a few years now. Here's a picture of an open grown hybrid butternut, across butternut, Japanese walnut plus butternut. This is a very nice tree in northern Indiana. It's been trimmed up a little bit now, but the owner had let the branches go to the ground. It was kind of neat to walk around underneath it. You could just pick the nuts right off. Some of them were actually right above the ground. It's a very healthy tree. Did get hit by a treetop tornado about 8 years ago. Took about a third of its crown out, but has since regrown. No butternut canker has been found on it. I was really worried about that because of the large wounds, the branches torn off. But these trees are quite resistant to butternut canker, the hybrids are. Here's a picture of a hybrid butternut growing in a forest. This tree is in northern Indiana as well. The bark is quite distinctive on these trees, but it almost looks like a cottonwood tree in a way. But this is a beautiful tree that's at least 65 to 70 years old, growing in the edge of a woods, competing with black walnut, red oak, and some pignut hickory. I found this one day walking through this particular forest. I couldn't believe I saw one of these growing back in the woods. These hybrids, but they do compete well, it appears. And I'll show you the next picture. Here we have the rest of the tree going upwards. It's about a 95 foot tall tree. Beautiful timber form. Only produces a few nuts. That open grown tree I showed you earlier produces about 3,500 to 4,000 a year. This tree here produces probably between what I can find anyway, about 80 to 150 nuts a year. Definitely more of a timber variety, but it does show its ability to survive in the forest. Excuse me. Here I have 3 butternuts I picked off of a tree. I took a picture of it one day. These are from a fairly large tree. The tree itself is about 5 feet in diameter. The trunk, open grown. These are in the husk. Butternuts are between 3 and 3¼ inches long. They crack out fairly well, about 22–23%. For butternut, that's pretty good. But the trick is trying to get ones that have thinner shells and better crack out. So I've been collecting lots of these different types of butternut and growing them, looking for selections eventually as they mature. Here's a picture of these are 4 different butternuts, 4 different other trees they came from. And you can see some difference in them. One thing about the hybrid butternut is they do back cross in nature occasionally back to one of their parent trees as pure butternut or back to Japanese walnut. So there's a lot of mixing going on. So the variability is all over the map with the nuts, but these are generally what I find when I collect the seeds for the state nursery here in Indiana. They sell them to the public. I'm not looking at this as a replacement for pure butternut. What I'm doing is trying to get these things out so people can have a tree resembling butternut and also for timber qualities. The nuts do taste fairly good. They most of the time taste like a pure butternut, but sometimes it tastes like a Brazil nut because there's some entry of the Japanese walnut flavor in these. Japanese walnut obviously is the parent of heartnut. Heartnut is a sport of the Japanese walnut, which is Juglans islandifolia. Here I have a quarter next to that rarer variety of hybrid butternut, the Persian versus crossed with pure butternut. That tree is a very shy bearer, only bears about 30 to 50 nuts a year. And as you can see, they look a little bit different. They do have more of the Persian walnut look to them, but they still are rough edged like a butternut. They almost look square when you look at them head on the suture of the nut. I don't eat these nuts very often. I plant them to see what I get out of them. So far, there's been a variety of seedlings I've had from these. Some look just like pure butternut. Some look just like Persian. Only time will tell how their survivability and resistance to butternut canker disease comes out. But again, this is a very shy bearing tree. I will say, I add on that tree, the Persian cross with butternut is a very nice looking decorative tree, be a good ornamental probably. It's not obviously is quote dirty end quote with nuts, but the leaves look really nice. They look a lot more like Persian and they're quite shiny. Here I have a picture of a Japanese walnut. This is just your regular run-of-the-mill Japanese walnut. Notice it's somewhat looks like a butternut, but it's a little shorter and it's very smooth. It doesn't have all the ridges and edges on it. These Japanese walnut, I find these quite often in people's yards and areas like around old farmsteads. A lot of times I find them, and they're usually a large, very low branching tree. They produce quite a few nuts, but they're not of a very large size. They do have a fairly good flavor, just like a heartnut. They're just a little bit harder to crack than a regular heartnut. But this is obviously one of the parent trees that if there's any pure butternut around, they'll readily cross. In fact, they cross very easily, the Japanese and the butternut. Here's a picture of some Japanese walnuts in the husk on the tree. I think there's about 7 here on this pedicle. That's very common. They usually have a lot of fruit on one pedicle. I've seen as many as 11 on before, but normally it's around 5 to 9. They're very sticky little fruits. Squirrels don't seem to bother them too much. I don't know why. Maybe it's just my area doesn't have a lot of squirrels where these trees are located. Here's a picture of that large hybrid butternut I had mentioned earlier, the black walnut cross with pure butternut. There's a couple of nuts hanging on a pedicle there. They are about 1 foot off the ground. His tree hadn't been trimmed, obviously, but it had really easy to reach nuts all over the tree for years, just above the ground, almost touching the ground. A very productive tree. And those nuts on that tree are generally in that 3-inch range as far as in the husk lengthwise. Tastes like a Brazil nut, this particular tree. Here's a picture of butternut canker disease on a pure butternut tree. This is one of the reasons I've been working with butternuts and hybrids is because there's not really a lot of research being done, and there's no really cure for this disease. And these are really nice trees that I keep finding them with this black oozing cracks and stuff on the trunk. That's indicative of the disease taking root. The tree slowly declines, and the older ones takes about 4 to 5 years where they finally die. You'll see the crown dying out, large branches dying, and then you have epicormic sprouts popping out, unfortunately. But the hybrid butternut that I grow is quite resistant. It's not immune. It can get this disease, but it's usually a much smaller infection and then it heals over it. I've seen this many times with the hybrid butternut. They carry some resistance from the Japanese parent. That's probably why that they seem to be resistant to this butternut canker disease. Here's something you commonly find on hybrid butternut. This is a walnut leaf mite, gall damage. It's not going to affect your tree's performance at all. I mean, it's just disfiguring and cosmetically not good looking. People ask me if they think it's got a fungus or something. It's just a mite. Very common with hybrid butternuts and Japanese walnuts. Occasionally you see it on regular butternut or black walnut. Here's a picture of a young hybrid butternut that I grew from seed. I grow lots of them from seed, but this one had the unusual leaf situation. It didn't live past the first season. I believe it's a genetic issue with the seedling. But I just wanted to show this to you as another thing that I can see with other trees too, but I've seen this with hybrid butternut a couple times. Here is a hybrid butternut I planted last fall. I direct seed on most of my trees anymore. And I sunk this hardware mesh around it in the ground to protect it from rodents. And then I have this weld wire cage around to protect it from the deer. This little seedling here sprouted approximately 30 days before this picture was taken, and is 26 inches tall at the time of this picture. Very healthy, came from a really nice mother tree. They establish very easily. Just got to protect them from the wildlife. Deer do love to eat the leaves, and the rodents, chipmunks, squirrels will dig up that nut even though the tree may be sprouted. So that's why I keep all this protection around it so it gets a good start. Here is a top grafted black walnut. We put a hybrid butternut on it. Jim McKenna actually did this graft, a good friend of mine from Purdue and a member of the Northern Nut Growers Association. It's a field graft of about a 3-inch diameter black walnut. And both scions took that he put into this. He did quite a few of these on one of my properties, and got really good response. A lot of them have taken. He's at about 75% take out there this year. Trying to collect some of this and keep it as in a repository of sorts out on my properties. Here's again this picture of hybrid butternut seeds in the tree. Hybrid butternut generally has about 3 to 5 nuts on a panicle. It's less than a Japanese walnut, but more than a pure butternut. Pure butternut's 1 to 3 normally. And I go and I look at these things usually this time of year, midsummer, to see how many are going to be there, because they start to fall from the tree around Labor Day. That way I can gauge my collection times. I do a lot of collecting of hybrid butternut, and I get those sent to the state nursery where they plant them out and then sell them, I believe, when they're 1-year-old seedlings. The seedlings are really nice. They look almost like 2.5 to 4 foot tall, almost like broom handles. They have pretty good root systems on them too after 1 year in the field at the nursery. Here's a shot of a one-day collection I did. I had a lot of collection days like this, but I believe there was like 13 bags, onion bags I use to put the fresh butternuts in. I don't want them to overheat much. So I put them in these mesh bags, and they weigh about 45 pounds, and you fill them up, sometimes 50. And I take those straight to the nursery normally, and they clean them off there, or I can take them to a walnut huller friend of mine who cleans off black walnut. He'll clean these off. One bag of these takes about 3 minutes to clean off, and they clean off very nicely. He'll charge a regular customer like 3 to 5 cents a pound to clean these off. So it's a lot better than running over them in your driveway or pounding them through a hole in a board. But I've had days where I've collected as many as 18 bags of these butternuts in a season. I will send to the state nursery generally about 30 to 40 bags like this for their needs. Best year I had a little over 30,000 good seed. Normally it's around 15 to 18,000 good seed each year. They seem to sell well. They run out of them a lot at the nursery in the springtime. Well, I'm open for questions now. There's a lot of things I could have talked about on the hybrid butternut, but I try to hit some of the basic pieces on it. I am one of the experts in the Indiana nut fruit growers on butternut and chestnut. So if you would like to talk to me more about that, we can just give me a call or email me on questions on hybrid butternut or chestnut. Thank you for your attention today, and good growing. Bye.
Hello, NNGA. My name is Leslie, and I'm presenting today for my father, Rodney Hart. He's having some technical difficulties with his microphone. Different Parallel Advanced Pollination Methods and Avant-Garde Thinking in the Almond and Pecan Nut Sectors in America by Rod Hart. Hello, my name is Rodney Hart. I currently live in Florida with my wife of almost 50 years, Jeanette. I've been part of the NNGA for about 20 years. I've been following almond and pecan pollination for many years and would like to share with you what I have learned and researched. Today, I would like to focus on 2 important topics. I will discuss why some growers are changing to self-fertile almond cultivars and why other pecan growers in the Southwest have eliminated orchard mates for cross-pollination. The first topic I would like to discuss is self-fertile almond cultivars. In the American agricultural nut sector, there have been some experimental and unorthodox changes in almond pollination. Some people believe that these new ways are the solution to a problem, while others criticize the new, untried, and untested answers, feeling that they are unsustainable. This new search for different types of pollination has been seen by some orthodox growers as a desperate solution to save money. So we're going to take a very brief look at solutions to almonds and pecan pollination problems that have been brought on by a trade war and the COVID-19 pandemic. Some nut farmers have experienced the economic pain of having their farming compensation drastically cut, and they are looking for an answer to economic survival. They're asking the question, can changing my pollination method help me to lower my annual planting costs so I can make more money and survive in this California almond farming environment? I'm going to start with the self-compatible almond cultivar search, which is global. Now, the word cultivar is a combination of the words cultivated and variety. A self-compatible almond cultivar is an almond tree that can pollinate itself, something that a normal California almond tree can't do. This quest has the potential to radically change the way almond growers farm in terms of pollinators and pollination cost with a single cultivar, Harvest Black. The problem is that these new self-compatible almond cultivars have not been proven by the 20+ years of nonprofit university testing, but by the commercial for profit method, and there are some risks in this method. Therefore, we don't have good scientifically backed data on the reliability of these new self-compatible almond cultivars. We don't know if they will last or make a profit for their growers. Some might also argue that planting these self-fertile almonds like Independence could be seen as gambling the farm on the success of an unproven tree. It is important to note that as they are growing these new cultivars, they're actually testing them for private almond breeders and nurseries. In the past, mutual pollination incompatibility of almond cultivars was attributed to inbreeding, but research has shown this is actually not the case. It's now an accepted fact that virtually all almonds are self-incompatible and need cross-pollination to set a crop. Although some cultivars are cross-pollen incompatible with other common almond cultivars, just like hazelnuts. So what is happening with these so-called self-compatible almonds? How are they self-fertile? The new self-fertile almond cultivar needs to be self-compatible with its own pollen and must be capable of fertilizing its own flowers. It must also have a self-pollinating flower structure. The structure of the almond flower must be such that the self-pollination happens at a high occurrence over a range of different climates and weather conditions for its growing area. It should also have a 20+ year orchard life expectancy. Self-compatibility of almond pollen is a very important piece of the puzzle. Self-pollination is the other piece, and this is a very complex trait controlled by many genes. Self-fruitfulness is influenced by several environmental and developmental variables, which is very complex. We can use this simple formula to help us understand the process. So it's self-fruitfulness in almonds equals almond pollen self-compatibility plus almond flower pollination. Now it's important to remember that pollen self-compatibility is controlled by a single gene and is easily transferred by breeding to a wild almond or related tree species. However, almond flower self-pollination is more complicated. The transfer of this trait is difficult, and this is where private plant breeders and university plant breeders earn their money. I would like to continue our look at self-fertile almonds with part of its backstory. So nonpareil is the #1 almond cultivar in the world due to its many commercial uses and high productivity, and is also the highest money-making cultivar in California. So why are people searching for self-fertile almonds if they make more money with nonpareil trees? Well, to answer this, we're going to examine a nonpareil planting method. So the planting pattern would be as follows. It would be, your first row would be nonpareil. The second row would be an early pollinator for nonpareil. The third row would be nonpareil. Your fourth row would be a mid-pollination season pollinator for nonpareil. The fifth row would be nonpareil. And the sixth row would be a late pollination season pollinator for nonpareil. So this 6-row plant pattern would be repeated over and over until the orchard is basically fully planted. This type of pattern provides compatible pollen for complementary cultivars so bees can cross-pollinate the different mother trees and set a crop. The new self-compatible cultivars like Independence and Shasta are self-pollinating and do not require multiple cultivars with different early, mid, and late flowers for cross-pollination like nonpareil. This is very efficient for the grower. Pollen from the male flowers of the same cultivar, such as Independence, can actually pollinate itself, its most valuable trait, and also other female flowers of other Independence mother trees, because the pollen is self-compatible if bees are present. Self-compatible cultivars like Independence appeal to growers because what it does is it eliminates the increased work of dealing with 4 or 5 different cultivars and allows them to grow one cultivar, and this adds up to grower efficiency. With just one cultivar in a block, all the multiple expenses and work efforts for their harvest, spray applications, and irrigation are reduced, and harvest crews do not have to shake later maturing pollinizers. This all adds up to a really big cost savings and labor savings as well. This is especially true for the cost of beehives for pollination. Having just one cultivar like Independence greatly simplifies the orchard owner's work effort. So I'd like to now examine lower bee pollination costs, which appears to be one of the 2 great forces driving self-fertile almond planting. When you reduce the number of beehives rented, obviously cost goes down. Many conservative Independence almond growers believe 1 hive per 1 acre is possible with the new self-compatible cultivars rather than the traditional 2 or 2.5 hives per 1 acre for some cultivars. So this equates to a 50 to 60% reduction in beehive pollination expenses, which in turn equals a big reduction in the almond grower's annual production costs. In conclusion, the reduction of beehive pollination cost is a major incentive for self-compatible almond cultivars like Independence. The other major motivation is the reduction in work effort you get when you go from caring from 4 cultivars down to just 1 cultivar. So just a little recent almond price history for you. Almond growers say that the world famous and #1 almond cultivar in America is nonpareil. And when Independence first started, the price between nonpareil and Independence was really close. However, the price gap has now widened again as nonpareil is once again in demand by traditional almond buyers. So these buyers are looking for the same almond they've always purchased, which is nonpareil, because they believe that it's actually better than Independence. So the almond buying market views nonpareil as a better kernel with more commercial applications. And in addition, nonpareil and Independence are in a completely different almond selling category. So let's survey some contemporary thinking in regards to the new plantings or planting of Independence. There's a group of almond growers that would like to plant the new self-compatible cultivars such as Independence and Shasta. However, they are reluctant to plant Independence with the current lower prices. Even with the reluctance of some cautious growers, self-compatible almond cultivars like Independence and other self-fertile cultivars are becoming more popular with almond growers as time goes on, and their California production acreage is increasing. And the reason is straightforward. It concerns profit margins or return on investment, which is ROI to the almond growers. Right now, almond growers are earning less money because of increased costs of beehives and trade war, and of course, COVID-19. Some almond growers believe they were working harder than necessary. And when you factor in little to no honey beehives and self-compatible almond cultivars, what this does is it represents a fundamental strategy for reducing their workload and increasing the almond growers' profit margins and ROI. Renting beehives to pollinate almond flowers is a grower's single most expensive growing activity. It's about 24% of their annual production costs. And these new self-compatible almond cultivars can reduce that number of 24% of the annual production costs for beehive rental down to about 12% or even 10% of annual production costs, or 0% if no bees are used. But Independence has other advantages. Everything an almond grower does with the cultivar Independence, he or she does just once, not 2 or 3 different times for 2 or 3 different cultivars. Not just harvest, but irrigation and more. With its grower efficiency, this tree has so much to offer growers. It affords them less work effort with the new self-compatible almond varieties, and they believe more money. Independence is the single most popular self-compatible cultivar and appears to have taken the industry by storm, even with all of its unknowns. Now, other nurseries say more self-fertile almond varieties are on the way, and many insiders believe that almond self-compatibility is a game changer for California almonds. So I find it appropriate to end this brief exploration of self-compatible almond cultivars with these prophetic words. We have new varieties, all self-pollinating. Zager, the breeder of Independence, says, I won't go backwards. They must be self-fertile, productive, and have good nut quality. So I'd like to move on to my second topic. The second topic I would like to discuss is why some pecan growers in the Southwest are eliminating their cross-pollination trees. In the Southwest, some pecan growers are no longer using orchard mates to pollinate new Western Schley, which is also known as Western plantings. Western is probably the most famous and most widely planted pecan cultivar in the Southwest region. Western produces a small, high-quality nut, and it's very productive. It's very well known as a self-pollinating cultivar, which has the potential to eliminate the need for an orchard mate. I'm not sure how large this trend is, but some pecan farm extension specialists are warning against experimenting with this type of pecan orchard pollination, so there must be some interest. So it's important to note that this pecan growing system does have followers, but it's unknown as to how many it has. I can't help but speculate that the almond self-compatibility search, coupled with Western's own reputation as a cultivar that's capable of setting a crop from self-pollination, has promoted this new system. These two concepts must have encouraged theorists to move beyond speculation to actually working out the cost of production and profit potential for a Western self-pollination orchard. Some people believe that planting an orchard with Western as the only tree makes total economic sense with its inherent efficiency of a single cultivar. And they believe that it's far less work caring for one cultivar instead of 3 or 4. Self-pollination in the Western cultivar happens slightly differently than with the self-fertile almond Independence. So Independence was developed to pollinate itself and would only pollinate other Independence trees with bees present. And of course, bees are optional with Independence. The pollen-sending cultivar Western does not pollinate herself, but with other downwind Western cultivars who have receptive female flowers. So what I'm saying is that Western trees are wind pollinated. These two trees usually accomplish self-fertilization differently. Circumstantial evidence indicates that certain pecan cultivars appear to tolerate self-pollination much better than others. Western appears to be one of those exceptional mother trees that can take self-pollination and produce a crop. Why? Well, low self-pollination may simply fail to materialize. So I can't give you a prediction percentage of failures compared to a success rate because no one is able to present an unbiased and enlightened data-driven model. And I think this planting system's success or failure will come down to simple economics of return on investment, ROI. If the ROI is in the profitable territory on the orchard owner's balance sheet, then this system is going to be declared a winner. If it is declared a winner, some may say the system is unorthodox or it's an anomaly or we're not sure why it works, but it works. When using self-pollination for the pecan cultivar Western, it may result in, number one, a possible lower nut set because of self-pollination, and also possibly missed pollination opportunities because of a lack of pollen. Both of these pollination faults lower production per acre. However, in all fairness, these two possibilities are not a logical certainty for these orchard owners. Number two, it has increased abortion of the nuts, which lowers production per acre. Number three, decreased pecan kernel percentage and nut size as compared to good out-cross pollinated nuts. The following information has been noted concerning pecan self-pollinated nut meat, and it tends to have around 17% less nut weight and about 11% smaller volume, which leads to our number four, decreased kernel quality from self-pollinated kernels. Now, when I say decreased kernel quality, I mean a lower percentage of fill for the individual nut. For example, a decrease from 60% nut meat to 56% nut meat per kernel. This, of course, means a lower price per pound for your pecans. My pecan conclusion all boils down to two advantages for the unorthodox Western pecan plantings. It's less work and less annual growing expenses. This translates into a lower annual production cost with this new system of using the pecan cultivar Western as a self-pollinated pecan mother tree. Everything a pecan grower does, he or she does once, not 3 or 4 different times, because with just one cultivar, all the multiple expenses for multiple cultivars for their harvest, spray applications and irrigations are reduced to serving just one cultivar. And that's a work and cost savings. Of course, there's that big question, right? Will it work? So if Western pecan growers succeed, they're going to be hailed as these big geniuses who are just avant-garde and ahead of their time. And if they fail, they will be mud and their enterprise will be characterized as foolishly adventurous and bold. This concludes my presentation today. Thank you for listening. I hope you learned something new and enjoy the rest of your day. Thank you.
Hello, this is Bill Reed at Southeast Kansas. I used to be an extension specialist in pecans, but I've since retired and am now got 30 acres of pecans of my own, plus apples, pears, peaches, blackberries, raspberries, and assorted other fruits. But that's what we're doing now. We are going to talk about training young trees. There's a few concepts I want to share with you. Talk about tree growth habits, what I call the 2-foot rule, the difference between corrective and directive pruning, the importance of dealing with stalked buds, and when to start training your tree. Pecan is apical dominant. That does not mean that when the new buds come out in the spring, it's going to just have one bud come out in the middle of the top of the shoot, and you're going to have a nice, straight, tall growing tree. When you grow pecans out in the open, when you have bud break in early spring, you'll get a whole bunch of buds at the very top of the tree come out at one time. And these buds are all clustered together because as the tree slows down in growth the previous year, the buds get closer together. So as you can see, we have a whole bunch of buds. If you left that alone, you end up with trees that have these multiple tops, what's also called crow's feet. And it's not what is desirable in terms of shaping a pecan tree. As you can see, this bigger tree here, first year, it had a whole bunch of buds, and then second year, it had a whole bunch of buds, and each year it does the same thing over and over again. Typically, if we listen to many people that talk about pruning pecan trees, they all learned how to prune trees by pruning apple trees. And you prune apple trees in the dormant season, and you go through and correct all the problems that were created by the growth the previous season. So this is what I call dormant pruning, is actually corrective pruning. As you can see, here's a pecan tree. You have all these crow's feet because of the growth habit of pecans. And you have all these things on top, and you'll eventually lose your central leader. So you have to come through and you have to prune out, and you take out a massive amounts of wood to maintain the correct growth form, which is a central leader right up the center of the tree. Well, I have started using summer pruning instead of dormant pruning, and I follow what I call the 2-foot rule. I keep 2 feet of the top of the tree or the central leader free of all lateral shoots. I limit the growth of side shoots to 2 feet of new growth per year, and then prune out any upward growing shoots on the lateral branches. So we end up with a nice straight tree. We have nice branches. It's important to keep branches, low branches on a tree, a pecan tree. Many people are over anxious in pruning. They want to take off everything because they want to get their tree taller. And what that ends up doing is you end up with a tree that grows so tall, it just falls over and you lose all kinds of form. By leaving some branches and what we call the trashy trunk down here, of all these leaves down here, we catch a lot of wind. And when you catch a lot of wind down here, you actually make the trunk gain in diameter or gain in strength. So that's our whole purpose of training a young pecan tree, is to develop a strong trunk that can support the tree for 100 years or more. Here's what the 2-foot rule looks like in practice. Typically, this is what a pecan tree looks like in the summertime. It can just be growing every which way. Typically, it likes to grow up on top, and you get a bushy top up here, and you'll lose the central leader. By pruning out and making sure you have at least 2 feet of top, and then tipping back the side branches to 2 feet long, you can regain your tree into a nice central leader. Just a few cuts in the summertime. Summer pruning is what I call directive pruning. And the reason I call it directive pruning is because we are actually, by pruning in just after bud break, what we're doing was we're pruning trees. And so shoots that are left, we're directing all the tree's energy to those shoots, hence the term directive pruning. You can see here, again, we have the top of the tree, multiple buds broke at one time, and you have no clear top. You can cut it down to 1 shoot and then remove these below it, and you have a nice, well-defined central leader. Up close, here's the top of the tree in the spring. Just with 1 snip, which I'm going to make right across here, I'll release this 1 shoot to become the central leader. And then I'll come down below and start pruning off these laterals. So it really doesn't take very much time to do it if you do it in the spring, and you waste very little wood growth. And you're directing the flow of the tree's energy to this 1 shoot. So as you can see, when we start here with a whole flush of growth, no central leader, we do the 2-foot rule, and we're down to a single shoot with no side competition. That does not mean that you completely eliminate all lateral branches. Below that, what you want to do is keep about 2 feet of no lateral branches, and that assures that your central leader will stay dominant. The one downside of forcing a dominant central leader is that you can get rapid expansion of the growth of the new shoot, and it forms stalked buds. Stalked buds will grow into branches, and those branches will actually have very poor attachment and cause problems later on. So you need to deal with those stalk buds. You can see we have several of them all the way up and down this stem. What is a stalk bud? Well, first of all, why stalk buds are important is in terms of branch attachment. What you want ideally is a strong branch attachment, a good branch collar, and this branch will have good strength and can handle the weight of nuts, can handle the weight of ice storms or whatever. This branch has a bark inclusion. This is very common in a lot of pecans, especially if people plant the trees and forget them. They end up with all these branches and with bark inclusions, and then they get a strong thunderstorm in the middle of summer, and then wonder why all these branches were split out. It's because of these bark inclusions. And I'll show you the genesis of these bark inclusions. This right here is a stalked bud. Like I said, they form typically on fast-growing shoots. This is the primary bud, secondary bud, tertiary bud, and this, of course, is where the leaf used to be. If you allow this to grow, you end up, this is a stalked bud shoot from the primary bud. You can still see the secondary bud hiding down under here. And of course, this is the petiole of the leaf. But you can see there's already a bark inclusion started. So these stalk buds are very important to get pruned out early in life. You'll save yourself a lot of headaches if you pay attention to that detail. And it's more of a problem when the trees are small and fast growing. As the trees mature and start bearing nuts, you really don't have a problem with stalk buds anymore because the trees don't produce that much rapid growth. Now here's an example of a shoot that actually had some of the stalk buds starting to shoot out or grow. And then come through and take out the stalk bud, clip them as close as you can. And here's the secondary bud shooting out, nice strong angle. And you can keep good strong branches on the tree this way. So you want to remove all stalk buds as the tree grows. And it's a lot easier to remove them when they're about this size, about 1.5 inches long. You can just take with your finger and pull it right out. You don't need to clip them with the clippers. Once they start to get woody and long like this, you are going to have to cut them with the clippers. On the lateral growth, you want to limit that growth to 2 feet of new growth in a single season. What you want to do is, if it gets too long, I've seen some pecan trees that are very vigorous, allowed to grow, and the limbs get so long, side limbs, lateral limbs get so long that they actually get heavy and drop down and droop and almost touch the ground. What you want to do is avoid that. So when they get to about 2 feet, you tip them back, and you see here's the tipping cut, and you want to tip it to a bud that's on the underside of the branch. So it actually will force new growth outward instead of straight up. The one advantage of doing the tipping is that you will force some dormant buds on older part of the branch to start growing. And so this actually gets tree more leaves and more density of the canopy. When do you start pruning? Many people, when they buy a grafted tree, or what I do typically is I always plant seedlings and then graft my own. But if you plant a grafted tree, they want to prune it right away, and you really don't need to prune it right away. Whether it's to graft the tree or to prune the tree, you don't want to mess with it until a tree has recovered its root system. Anytime you transplant a tree, it is very slow to recover its root growth. So it's first thing it's going to do, usually about 2 years after transplanting, a tree will sit there and do nothing but grow roots. And you'll be so dissatisfied and say, oh, this tree's just not growing. These pecans will never, I'll be dead by the time I'll get any nuts on it. What's going on is the roots are growing to establish that tree. Once the roots get well established, all of a sudden, bang, the tree will start growing. And you'll get, once you get 2 feet of new growth, you can either graft the tree at that time if it hasn't been grafted, or you can start to train the tree for a central leader. Like I said before, most of the time when I'm growing trees, I start with seedlings and graft my own. It's not that I don't trust nurserymen, but I don't trust nurserymen. I've had some bad experiences in the past, and I like to make sure that what I got is exactly what I want, and at the place I want it. So here's a graft that was placed, and you see lots of growth here. What I'll do is right after the first summer, middle of the summer, here's the little signwood piece in here, is I'll choose one shoot from that signwood piece and to grow as my new leader. This limb was left on here as a support limb to make sure we have plenty of energy going into the root system. And I'll take that off next year. So I start training during the first summer, right after grafting. I like to keep the tree balanced throughout the young life. Especially right after grafting, I like to inspect my trees about once a month, make pruning cuts from May until August if necessary to make sure that I follow the 2-foot rule. The central leader has 2 feet that has no laterals on it, and that the lateral shoots are limited to 2 feet long. Don't get in a hurry to remove lower limbs. That's the biggest mistake people make in pruning young trees. I usually wait until the lateral limbs are at least 1 inch in diameter before I start taking them off. Now, you don't want lateral limbs right on the ground where it makes it difficult to do any kinds of operations around the tree. You want them up at least 18 inches. But you do not need to cut down off all lower limbs to make the tree grow faster, because it won't. It actually slows them down. In the long term, our role of pruning changes as the tree starts to bear nuts. When the trees are young, we prune often and early to maintain a good, strong central leader. And the reason we want a strong central leader is because we want a single straight trunk. It makes all management of the tree later on much easier. And that's basically shaking the trees with mechanical shakers. There will come a time when the trees get too big that you can't do a lot of detailed pruning. And usually my rule of thumb is I will stop pruning when I can't reach the top from a 6-foot ladder anymore. Once it gets that tall, I'm not going to mess with it anymore. I've got at least 10 feet of trunk established, and that's perfect. By doing the pruning at a young age, you develop a strong framework for the tree, so it helps the tree combat wind damage and ice storm damage. Now, there's a lot of information about pruning that that you can find on my blog, which is called northernpecans.blogspot.com, and you can see about every year I talk about pruning, and this one was posted past June about pruning. And I show different trees all the time, different examples, all in full color pictures. So if you want to learn how to prune trees, I would suggest going on to the Northern Pecans blog and going back and just searching the search bar for training young trees, and you'll find a whole host of information on pruning young pecan trees. It is different than pruning apple trees, and I think you'd benefit greatly if you learn about the 2-foot rule and practice the 2-foot rule. That's all I have for you today. And if you have any questions about this, I have provided the Northern nut growers with a manuscript detailing the pruning techniques that I've described in this talk. Thank you.
My name is Carl Albers. I'm with the New York Nut Growers Association English Walnut Project, and I'll be talking to you a little bit about the project for the next few minutes. Why grow nut trees? Because nuts contain healthy fats, vitamins, minerals, and are packed with antioxidants known to possess anti-inflammatory and anti-cancer effects. They're just a good thing to add to your diet. Because they're perennials, no annual tillage is necessary. Orchard trees and the understory enhance soil structure and increase soil organic matter. Infiltration in the orchard increases and more water is stored. Folks may not realize it, but for each 1% increase in soil organic matter, increases water storage by roughly 20,000 gallons per acre, which is pretty amazing. So taking this all together, the fact that we've got a perennial ground cover, organic matter is increasing. What we're doing is we're enhancing the hydrologic cycle, which is 95% responsible for cooling the planet, according to Walter Janney. Now, Walter is an Australian climate scientist and soil microbiologist, and he writes that for the past 4.2 billion years, water has governed over 95% of the heat dynamics of the blue planet. So Walter makes a case that it's very important that we work on getting CO2 emissions down and CO2 levels in the atmosphere down. But a more immediate thing that we can do is improve the hydrologic cycle. And he adds that over the past 300 years, we have cleared and burnt forests, oxidized soil, organic matter, and created over 12 billion acres of man-made desert. This has greatly diminished the capacity of over 70% of the land surface to infiltrate and retain rainwater and sustain its former transpiration, cooling, and cloud dynamics functions. To cool the planet, we need to restore Earth's soil carbon sponge, revegetate land surfaces from which vegetation has been removed, and maintain vegetative cover for as much of the year as possible. So that's a big reason why growing nut trees, planting and growing nut trees is such a valuable thing. So why Juglans regia? Well, one of the important things is because the nut separates from the husk, and this eliminates one unpleasant processing step. With black walnuts and butternuts, you have to physically remove that husk, and it's a messy process. The best English walnuts produce large nuts with a high percentage of nut meats that crack out easily and taste good. They're highly nutritious, as I mentioned before, and well suited for home use. Another plus is that consumers are very familiar with English walnuts. EWs can add product diversity on small farms. So this just shows the nut dehissing from the husk, and it'll soon fall to the ground and make harvest easier. So what are we doing with the English Walnut Project? What are our goals? We're looking for adapted regular bearers of easy cracking nuts with good flavor and no bitterness. And that's in New York State and the northeastern US and eastern Canada. We'd like to collect sign wood from those trees to make clonal copies for further evaluation. In addition to that, we have started to trial known cultivars throughout New York State. And currently we are trialing Ames, Bower, Broadview, Combe, North Platte, and Young's B1, all sourced from the Grimmel Nut Nursery in Ontario, Canada. And with those trees, we want to monitor their adaptation to our New York climate. So that's basically zones 5 through 7, and use these as benchmarks. Ernie and Linda have looked at these trees, studied these trees for a long time, and selected them, and we just want to see how well suited they are to our New York climate and soils. Down the road, we'd like to procure and evaluate genetics from other humid, cold climate areas in Europe and Asia. Select for the best genetics through statewide trials, and evaluation and genetic progress we realize is going to take decades. So it's important that we be willing to cull inferior trees, especially when you're thinking about evaluating seedlings. It may take hundreds or even thousands to come up with one winning tree. And in order to do that, we need to recruit outstanding collaborators. We have a good small group of collaborators now, but it would be nice to add more to that core group. If you're interested in finding out more about our English Walnut project, you can take a look at our website, ninja.org. And on the website, you'll find a brief history, an overview of the project. And then there's 3 main tabs there. There's one on how you can join our search for superior individuals. Probably the best thing we can do is find those best trees that are growing already through New York State and have been there for years. We collected scionwood, for example, from a tree last year that's been growing for 40 years, and there's a bunch of those around. There's also a tab on how you can help us trial and evaluate the best trees. Like I mentioned, we have a good core group, but we could use more folks. And again, they don't have to be located in New York State, but we would prefer people that are located in a climate zone similar to ours. There's also a section about supporting our work. It costs about $50 to clone and distribute each tree. Seedlings would be less cost than that, but this is all privately funded, and of course, we could use financial support. And then finally, there's a section on growing English walnuts on the website. It's brief and pretty bare bones, but it may give folks some ideas on how to grow Juglans regia. So botanical illustration here of regia. And I'd point out that it's a monoecious tree, meaning that it has both male and female flowers on the same tree, but they're separate. And regia can self-pollinate, but quite often what happens is that either the male flower releases pollen before the female flower is receptive, or vice versa, the female flower will become receptive before pollen is released, and therefore having a mix of those 2 types of trees in an orchard is important to improve pollination and nut yield. So what are we looking for as far as the desired characteristics go? We'd like trees that are hardy to USDA Zone 5. And we've found some trees in Zone 5. Most of the ones we find are in Zone 6. And there's a number of trees that are doing just fine in Zone 6. In Zone 5, production is more sporadic because of damage from late spring frosts. We'd like trees where the nut falls free from the husk most years. This is an indication of a couple of things: adaptation to the length of season, and also resistance to walnut blight, which can interfere with the husk opening and dehissing. We'd like large thin shell nuts with a high percentage of nut meat, nuts that crack out easily, have a mild nutty flavor, and no bitter aftertaste. And some of the nuts do have kind of a sweet flavor, a few of them. Late flowering and late leafing to escape late spring frosts. That's something that breeders around the world are looking for. And we do see some differences there. We'd like early maturity, so it's adapted to our season. And we also would like trees that retain their leaves after the nuts drop so that they continue storing carbohydrates and getting ready for winter. I have a question mark on lateral bearing. A lot of breeders are looking for that because it increases, it makes it quicker to come into production, and yields tend to be higher on lateral bearers. But I've also learned lately that terminal bearers, as a rule, may be more disease resistant overall than lateral bearers. So I would prefer to have a disease resistant terminal bearing tree as opposed to a higher yielding lateral bearing tree. But you can find lateral bearers that are disease resistant. So adequate insect and disease resistance is it's very important, especially walnut blight resistance in our humid climate in the eastern US. And that's probably one of the biggest things that we need to keep in mind. Dwarf size would be a plus. I don't know if there are any negative genetic linkages associated with dwarf size, but dwarf trees would be easier to prune and easier to spray, so that would be beneficial. So just a few things on getting the trees off to a good start. You want to dig a hole that's wider than it is deep. Martin Crawford in England advocates digging a square hole, and the thought is that it keeps roots from circling in the hole and gets the tree off to a better start, develops a better root system, etc. I find that, planting depth is very important, and I find that putting a rod across the hole really helps me to get the height adjusted better than if I don't use a rod. So here I'm using a thin fiberglass rod, and that works really well for height adjustment. Most of the land I'm planting on is only moderately well drained. It's not well drained, which would be more desirable. So I try and plant just slightly elevated above the background level, and that helps with drainage around the tree, which is important. The other thing that I find is that, especially if I dig the hole too deep, then the tree will settle. And so I'd rather have the tree a little bit too high than too low as compared to the background soil level. Weed control is critical, I think. Grass is very, very competitive with trees. And what you're seeing in this picture is weed control through a combination of wood chip mulch, hand weeding, and this year I've been experimenting with EcoBlend herbicide, which is an OMRI approved herbicide. Its main component is soybean oil. And it's basically what it does is it just kills the foliage above ground. Works a lot better on a hot sunny day, and works pretty good on grass, which is the number one thing that I'm trying to control. A lot of the other weeds are pretty easy to pull by hand. Like I have in this field dewberries and butter and eggs, and I can pull those pretty easily. But grass, especially if you let it get away from you, it's hard to pull. So this is working pretty good so far this year. It requires multiple applications though. So aftercare is important, and through the first season, you want to water weekly, especially during dry spells and extreme heat. You want to check the rootstock for suckers every few weeks and clip those off. This can happen for the first 3 years. Also, I like to weed inside the tree tube to keep humidity down, and it's important to do that going into winter so that you don't create a habitat for mice. And the other thing is to keep the orchard mowed short going into winter. So with that, I'll end and appreciate your attention and thank you very much.
Thank you for remaining for the question and answer session. I assume I'm on. And we have at least 3 of our presenters with us still to answer questions. And if I get to the top of this. So the first question, I guess, is for Carl, and it's for John Kelsey, and they would like to know, how tall should the white pine be before you plant a black walnut? And John, you're still muted.
There, I guess I'm unmuted. The white pines are about as wide as they are tall. So if you wanted, I was thinking about they should be 12 feet wide, so they would be 12 feet tall, somewhere in that neighborhood, on the 16-foot centers. That would leave you 4-foot aisleways. But really, the width is more important for the pruning.
Thank you, John. And the question that was asked is, this is for John also, what is the spacing between the white pine and the walnut rows?
Oh, within the rows, it was 8 feet.
And the white pines were planted at 16-foot wide rows before the walnuts were planted.
Yeah, so it ends up 8 by 8.
Okay. I think the next question is probably one that Gina has to answer, is whether all these presentations will be available online. And I believe the answer is yes. They will be posted in the members only section on the NNGA website.
That is correct.
And you should give us, I think, I'm going to say a month to get them all up posted.
Yep, that is 100% correct. It takes quite a bit of time to upload presentations because they're quite large videos, but they will be available under the member only area. So just like I talked about in the early in the video earlier today, there'll be a button that'll take you to the videos so you can watch them at your leisure. And if you have any other questions or concerns, feel free to email me at contact@nutgrowing.org.
Okay, I believe the next question is for Nick, and that is whether he's experiencing bunch disease in his butternut, in the butternut plantings, that either the existing ones or the new ones. Now, Nick, okay.
No, we haven't had that problem yet, so hopefully we continue to avoid it.
And I might ask Bill if he's seeing bunch disease in any of the plantings of the hybrid butternut that he's putting out.
Yes, I do see a bunch in it. It just seems anecdotally, for me anyways, that bunch is a bigger problem with anything that has Japanese in its background, Japanese walnut, Iolanthifolia. I see it less in pure butternut than I do hybrid, actually. But it does occur from time to time.
Thank you. I guess this is probably for Nick, and is when you're grafting your butternut to black walnut rootstock, does that reduce the incidence of butternut canker?
I don't think so. The graft union, I mean, yeah, the black walnut area right at the ground does protect them from cankers right at the soil line, which tend to be the most lethal ones, but it doesn't impart any resistance to cankers on the butternut part of the tree above the graft union, so they can still be girdled higher up.
A question I had well, relates to the inoculation method, and I didn't catch it or on how you plan to inoculate. And is butternut canker, do you have to worry about different strains so that you use multiple strains when you do your inoculations?
Yeah, that's a good question. So the inoculation method is very similar to what's used with chestnut screening for chestnut blight resistance, where you take a little plug of the agarose with the fungal culture in it and tape it onto make a hole through the bark and tape it in there. As far as strains, butternut canker disease has really low genetic diversity. It's almost all the collections of it that have been made in North America are genetically uniform. So we don't worry about using separate strains of it for inoculations.
Okay. Now I'm got to remember which presentation this was. On your butternut, and this is for Nick, on your butternut, you showed a planting that was put on commercial property, and they were a little bit curious. What special things did you have to do to be able to do that?
You know, I don't have a great answer for that question. It happened before I started here, and it was mostly Jim McKenna who arranged that. So I can I can ask him and get back to you, but I don't know how Jim figured out how to do that at the furniture factory. But it's a good site because it's so well maintained and is already fenced. Anyway, that ended up being our most productive butternut planting so far in terms of nut production.
I might ask Gina, if Jim McKenna is on, can you promote him to be able to answer that question? I didn't get him. Jim, you're still muted. Okay, I'm going to go to the next question and see if Jim comes on here in a little bit.
Hey, you guys. Hey, can you hear me?
Yes.
Yes?
Yes.
Hey, sorry, I just got a call I had to take. Here, hold on. Let me hang this thing up.
I think we lost Jim, though. All right. There was a question on where, Bill, where you're located, and you want to answer that? Or where's the area where you're collecting your hybrid butternuts?
Mainly northern Indiana, the top two tiers of counties. I'm in Marshall County, but I collect them throughout the the entire tiers of the northern part of the state, and a few in also in Michigan, a couple counties in Michigan. Branch County, I think, is the main one. But that's where it's located. And as I say, I live in Marshall County, and I have plantings in both Marshall and Fulton County, which are close by.
Okay. I'm trying, we haven't asked Rod any questions, and I may have to go to my list. And one of the things I was curious, Rod, is does Westerly show the characteristic of overbearing where the growers have to go out and do thinning to get mature large nuts?
That's a good question. Basically, when you have self-pollination, you get a smaller nut. It's a lower percentage of nut meat weight, and it's a lower percentage of weight for the kernel. And that's the best I can do for you right there. It's really not a system that the farm extension advisors are promoting. They're against it. So it's kind of the opposite of English walnuts out in California, where they accept planting like a Tular or Hartley or a Poe with no orchard mate, because they're able to do that. And pecans they don't generally promote that. It takes a special kind of pecan with you have to look at the pollination charts to look where they might all be crossing one another for their male and female flowers to be able to do that. I hope that answered your question.
I think my question had more to do with during the growing season, when you see that there are some of the pecan trees are producing too many nuts, it's advocated to go out and shake and remove some of the green nuts so that you get a good crop of the remaining nuts. Does Westerly show that characteristic?
Yeah, Western is a high producer, and so anytime you have a tree where it's going to be overproducing in one year, it could lead to a low production or no production the next year. So if you have the ability to shake a tree when you have that kind of overproduction, and usually they say if it's a large nut, no more than half of the terminal should have nuts on them, and each terminal that has a nut on them should have no more than 2.5 nuts per terminal. Now you might ask, how do you get 2.5 nuts per terminal? You get one terminal may have 2 nuts per terminal and the next one 3. That's what I'm talking about. And so yeah, if you can shake, you shake, but Western is just a tree that the people who buy pecans, they like it. The people who eat pecans like it. And it's able to be a special mother tree that can actually pollinate itself.
One question, Rod, that might be of interest to the members is what hardiness zones are the almond, those 3 almond cultivars that you mentioned, adapted to?
For the almonds, they're all grown basically out in California. It's almonds grow in about 4 or 5 places around the world, which is why California grows 80% of the almonds of the world, the whole world. I mean, the Indians from India and the Chinese in China said, well, we don't believe that. They tried to go outside that and it didn't work. So when you grow almonds, you only grow them in California Central Valley. And I think that's 9 or something like that, 8 or 9.
Thank you. Let me see. A lot of these questions have one upvote, so it's a little hard to pick out which ones I should be doing here. Okay, Carl, there was a question that with climate change, moving our planting zones north, Do you think at some point the things you're collecting, growers in Iowa may be also able to grow Persian or English walnut? Carl, you're still muted. Carl, you're mute. Okay.
I would say yes. In fact, there's probably some trees that they could grow now if they could get their hands on the right material. I've heard of English walnuts actually producing in zone 4 locations in either the eastern US or Canada. But obviously, you know, the problem there is late spring frosts. But you do hear those occasional trees.
Carl, if members in Iowa had Persian or English walnut growing there that they knew of that met some of the desirable characteristics you had, is the New York Nut Growers Association interested in getting sign wood from those trees?
Yes, definitely.
We had a lot of chat in the question and answer session. Nick, there was a question on what percentage of the trees in your large planting are true butternuts versus hybrids. I believe you probably answered that in the question in your presentation, but can you address it again?
Yeah, sure. I think it's like 35 butternut families and 5 or 6 hybrid families. So that works out to being, you know, between 10 and 15% hybrids. And the rest is all regular butternut. So the spacer rows are all butternut that are going to be inoculated later on.
Bill, there's a question about what kind of variation you see in husk size and nut size among the hybrid butternuts that you're collecting.
Mainly, it seems that the husk is thicker than a regular butternut. That's what I'm seeing most of the time. I showed pictures of some nuts in there were 3.25 inches long. There's a lot of husk there. The nuts are fairly good size, bigger than an average butternut after you've dehusked them. But definitely a thicker husk is on these hybrids than there is on a pure butternut.
There was also a question with your planting method. How do you keep the squirrels from getting to the nuts?
Oh, that's the $1 million question, isn't it? I don't really have a real good answer for that one. I have a lot of other nut trees planted nearby, that oaks and things of that nature, that I'm hoping that the squirrels will find them more palatable and easier to open than a butternut. That's normally what I do. I have a lot of shellbark hickories I grow too. Sometimes these big thick shellbark hickories, you about trade 2 butternuts for one of those practically. But yeah, if I have other food stuffs available nearby, I can try to keep the squirrels off that way. I don't kill the animals. There have been times when I've put piles of black walnuts out in the corner of a field, and I'll go to those and they'll stay away from my other nut trees. But it is a tough question. Squirrels are our #1 enemy in nut trees.
A question I might follow up. You showed the protective devices that you use. When do you go back and remove that hardware cloth or the galvanized wire cages?
The galvanized hardware mesh that's around the ceiling, inside the weld wire fencing, I'll generally keep that in there until the tree is about 2 to 3 inches in diameter. It isn't sunk far enough in the ground that it gets involved with the root system, but it just protects it in the winter from burrowing rodents that might gnaw on it. Once they get to about 2 or 3 inches, they're pretty safe in my area anyway. I try to keep the weeds away from them. You know, as long as you don't have a lot of mulch and weeds around those trunks in the winter, you won't have too many troubles with them. But when they're young seedlings, they do get chewed up if you're not protecting them. The weld wire fences, I keep those on there till the trees are 10, 11 inches in diameter. The deer around here, the bucks are corn fed, so they get pretty good sized. And then I have basswood trees that are destroyed every year that are 10, 11 inches in diameter. Not much bigger than that, but definitely they love to rub against smooth bark trees, and hybrid butternuts and butternuts in particular are their favorites if they can get to them with their antlers.
Yeah, I don't believe we've asked John any questions, and so one that I would like to ask him is whether he thinks there are any shrubs, tall shrubs that are suitable to use as trainers in his approach to natural shedding of branches on walnut.
Well, yeah, I thought a lot about that, and I can't think of anything that's native. I know some people have tried autumn olive, but I wouldn't wish that on my worst enemy. I've thought about using sunflowers to kind of change the spacing around there. So maybe we'll try that. I have a guy that's interested in trying it.
Have you considered your hazelnuts?
Well, yeah, that might work. I haven't really thought about it, Jerry.
Okay. I believe there was a question in here on how you clean butternut or remove the husk from butternuts. I don't know. I guess that would be a good question for Nick or Bill.
I can answer for myself of what I do. Hammond's out of Missouri, the black walnut kingpin in this country. They have set up hauling stations around my state of Indiana, quite a few in the Midwest. And I have a friend that is one of the hauling stations, and I'll run my butternuts to him, and he runs them through for me. He doesn't even charge me. He used to charge me about 3 cents a pound, but you could take a 45, 50-pound bag of those hulled butternuts, run them right through that walnut huller, and just a couple minutes, they're completely cleaned off. It's like a barrel-like device with chains in it that swing, rotate in there, and they just knock all that sticky green husk and black husk and whatever right off, and they come out really clean after that. That way, if I had to store them for longer, I don't have all that husk on there to heat up the seed. I don't want to damage the kernel or the embryo, so that keeps them pretty clean. So that's a good. If you get a hulling station, ask the guy if he can work with you. It's much easier than throwing them in your driveway and running over them. Believe me. I even see these people pounding through a hole in the board. Don't do that. Just find a hulling station. You'll really find that's a much easier way to do it.
This is probably for Gina. How long is this session to go for? I said earlier 12:45 or 11:45. Is that, or 12:45 Central Time? Is that correct?
Yes, that is correct, Jerry.
I don't know which. There was a question about whether you ever harvest your hybrid butternut trees for sale, the lumber for sale to wood carvers. I assume that is for Bill.
No, I haven't, but I do know that in this area, because I've had a lot of big mother trees over the years I've collected, a lot of them come up missing because there was a timber sale. Apparently the wood's a little bit heavy, has a heavier and denser capacity than pure butternut. And I've been told it does turn very nicely, has a good satiny finish to it. there was I remember just an example, I knew where an old farmstead was where there was about a 4-foot diameter mother tree and lots of younger 2-foot diameter trees around it. And I took some foresters to look at it one time over in Steuben County, and come to find out that the owners had a timber sale for cherry and black walnut, but the timber buyers also took that mother tree. They actually dug the entire stump out of the ground too for veneer, apparently. That's the value they saw in that. So if that gives you an indication, there is some value in it. And I had a picture of a forest grown hybrid butternut, and one of the forester buddies that was with me a couple years ago looked at it, and he said it's about 26-inch diameter tree and it's almost no taper in it. He said that was a $4,000 tree if it was on the market today, he said, but they have the capacity to be a valuable timber tree as well as a nut producer.
This question was for Rod, and that's whether Westerly is the only pecan cultivar that's self-fertile.
That's another good question. No, it's not. When you look on some of the pollination charts, you'll see Western or Desirable or Cherry Lee. What you're looking for is a tree that flowers across very early, mid blooming, late to late blooming. And not all trees do that, but the trees that I mentioned do. And so a tree like Western, if you had 20 trees and you numbered them 1 through 20, number 1 would never self-pollinate itself. It would pollinate other trees, but it would have to be early in the tree that it would be pollinated would have to be, say, either mid-season or late. And that's what makes that possible. They also should be self-compatible with their own pollen. But when you look on, again, the pollination charts, you'll see that. You see some trees are just apart for the male and the female flowers, and others are like that. That means that there's a lot of different flowering times, from the very early to mid to late to very late. And that's what makes it possible.
Bill, there was a question about, do you know the origin of the Persian by butternut tree that you showed the nuts from?
Yes, a late friend of mine on a farm nearby here, he did some cross pollinations many years ago of different types of nut trees, and that was one of them that he tried with, because he has a number of Persian walnuts on his property, and he also had a lot of butternuts there too. And he came up with that seedling that looked different. So after he had done the pollination, so he planted that. He also had a cross with the black walnut, and he thinks it was Persian, and it's definitely a different looking tree. But he put them all together, and actually I have a picture on Facebook I put out there a while back of these trees, all three of them, a pure butternut, a Persian with butternut, and a black walnut with Persian. He had done a lot of this when he was a farmer. He just found out that pollinating trees seemed to be another thing to do. And that tree is still there today. It's beautiful. It looks like almost like an ornamental tree. It doesn't have, as obviously, as I mentioned, doesn't have a lot of nuts on it. So it's not much of a problem with nuts. It still has the petioles and the leaf fall, but all trees do. But it's a fairly fast growing tree. The seedlings from it, they don't all look the same. They're different. I don't think any one of them looks the same as another one. Just that mixed heritage apparently.
Going back to some of what I learned when I was an active scientist, McKay did a bunch of work on hybrids, and he basically found the F1 of Persian by black walnut produced very, very few nuts. And it wasn't until you got to the F2 that you started to get nut yields. So that tree needs to be back crossed to, I think, to produce a seedling that will produce nuts for you. Okay, this question is for John, and that is, at what point in the management scenario you presented are the nurse trees removed to release the black walnut?
Well, at our planning and kind of the plan that we have for Blennerhassett is not to remove them at all. We're making walnut trees that are so tall and slender that we're afraid to remove the trainers, that they'll bow over. So the pine trees here are losing their health. You can tell it by the density of the shade. And I think the walnuts are going to take care of it for us.
And the pine trees, are they of sufficient size now that they are of commercial value if you could extract them from the planting?
Yeah, but I think we'll just let them die in place.
Okay.
It would really be dangerous to put a harvesting equipment in there, and they're very limby, and there's no market.
All right, I think I basically have pulled most of the questions. I can look and see if I found anything while I was listening.
One other little item, Jerry, is that those trees in there have never had any nuts on them. So by doing this funny thing we're doing, forcing them up like that, they're completely occupied with growing. And
I guess at this point, I would ask the presenters that are on, do you have anything you would want to add to your talk that based on something you heard on someone else's that would be informative to our members?
I've had some people ask me about agroforestry, using black walnuts as their primary tree crop, but wanting to know what they could plant with them. And I'm not a forester, but I use a lot of observation on things. And one thing that I thought might be a good idea would be pawpaws. You can interplant pawpaws in the rows with black walnut. Pawpaw will get about 20, 25 feet at its highest. Has large leaves, can shade out the ground, is not antagonistic with black walnut, and you won't have to worry about plowing the soil and damaging roots of the black walnut. Plus, there is a market for pawpaws, especially if you have the cultivated varieties. So that's something I've been telling some people that are thinking about agroforestry. Maybe I'm stepping out of my range of what I should be saying, but I've got a lot of pawpaws on one of my properties, and wherever there's a lot of pawpaws, black walnut does very well. It's an indicator of really good walnut soil normally, but there seems to be a compatibility situation that could be utilized there. It helps shade off your butt log up to 15, 20 feet and keep other stuff down. Just my 2 cents worth anyway.
Okay. Gina, I assume it's okay if we finish the session early. And so I'm going to say, if to all the participants who are still on, if you posted a question and I failed to bring it up, make sure ask Gina for the contact information for the presenter that can answer it, or plan to join the discussion groups tomorrow morning and ask your question again a second time. Or the third option is to go to our website and post it on the forum and hope that some of us will come back and answer your question in that method. I'm going to say this concludes our session on our other favorite nuts. Please plan to join us again at 1:15 when we will have a very short business meeting before we start the session on business of orchards. Thank you, presenters, for an excellent set of presentations, and our participants for an interesting set of questions. See you at 1:15.
Bye. Thanks, everybody.
Thank you very much.
Gina, are you still on to capture the Q&A?
Jerry, I think she is going to do that.
Okay.
Yeah, I'm doing that right now.
Yeah, she'll be fine.
I think there was maybe one question for Diana that showed up on somewhere. Is there anything else I need to do?
You did a great job, Jerry. Thank you.
All
You
right.
did. That was a lot to handle.
Okay. I'm gonna leave then the session and come back at 1:15.